Hello, everyone, and welcome to Addressing the 2023 OWASP API Security Top 10 event. Today's webinar is sponsored by No Name Security and produced by Actual Tech Media. My name is Keith Ward. I'm with Actual Tech Media, and I'm excited to be your moderator for this especially timely presentation. But before we get to today's content, we do have a few housekeeping items you need to know about that'll help you get the most out of this session. First of all, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. At the end of the presentation, we'll also have a dedicated Q&A session, so keep those questions coming. Now, that Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh is the first thing you want to do if you've got any audio, video, slide advancement issues. But if that doesn't work, let us know in the Q&A and we will provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find numerous great resources, including a link to the Gorilla Guide Book Club, where you can get access to our huge, vast library of resources on technology topics. In the handout section, you'll also find a link to the Actual Tech Media Events Center, which has our calendar of upcoming events. We have a lot of great ones coming up too. So check them out and sign up today. Third, at the end of this webinar event, we'll be awarding a $250 Amazon gift card to one lucky registrant, and you do need to be in attendance during the entire event to qualify for the prize. If you're into that kind of thing, the official terms and conditions of today's prize drawing can be found in the handout section. And with that, let's get to today's fantastic content. I'm excited now to bring on our expert presenter, Philip Verlooy, the field CTO for No Name Security. And I'll be joining Philip after his presentation for some Q&A. So Philip, the floor is yours.
Hi, my name is Philip Verlooy. I'm the field CTO at No Name Security. Thank you for attending our session on the OWASP API Security Top 10 for 2023. So I'll sort of walk you through the changes of this fairly newly released version of the OWASP API Top 10. We'll talk a little bit about some critical capabilities that we feel, but also the industry at large, including industry analysts, feel are needed to address these issues in the top 10 and beyond. And then I'll sort of wrap up by showing you a demo of the No Name Security platform in relation to the OWASP top 10 list, of course. So, what is the OWASP API Top 10 and why did we need a new version? So, the OWASP, or the Open Worldwide Application Security Project, is a sort of free for all community. Everybody can join. They provide a lot of documentation, training, but also tools and technologies specifically around application security. So their goal really is to make sure there's no insecure applications anymore going forward. We have a long way to go to achieve that, but it's a noble goal nonetheless. They're most famous probably for their top 10 list, specifically their web application security top 10 list. But as this session sort of shows, they also have one dedicated to APIs. And for example, more recently, they did one on LLMs as well. So the original API top 10 list was created in 2019, I believe released on the last day of 2019. But since then, we've seen that APIs have sort of become the leading attack factor. There's a lot of publicly disclosed breaches that we see on a weekly basis involving APIs. The usage of APIs has really skyrocketed as well. It's typically the way that we build new types of applications. The way that we bring services to market is on the basis of APIs. And security is still lacking around APIs. We see that a lot of folks try to or attempt to address API security concerns by using more traditional web application security tools. And as the OWASP Foundation rightfully points out, which you see on the slide below there, is that a product like WAF, for example, can't really fully understand the intricacies of each custom API-based application. So it won't really address those concerns. So why does a list like the OWASP API Top 10 matter? Everything will be API-based is sort of our thesis. And when I say everything, it's mostly, of course, new app architecture. So think about distributed architectures, microservices-based environments and so on, those are built on the basis of APIs. Think about consuming a service from a public cloud vendor. Those are all powered on the basis of APIs to a large extent. We see that existing tools don't work. So, um, you know, we see breaches, public breaches being announced, and so on. So that sort of means that those tools aren't really sufficient in protecting these environments. um, Even in our own customer base, if you look at the people that we're helping with these issues, all of these customers, they had these existing tool sets like API gateways, like web application firewalls, but they needed to extend those to bring in specific API security context to address some of these issues that we'll talk about going forward. And then ignoring them is risky business. Just recently, for example, we had a public breach from Duolingo where they lost, I believe, 2.8 million customer PII records on the basis of a publicly exposed API. Another example of this week, I believe, was Trygg-Hansa, a Swedish insurer, was fined about 3 million euros for losing customer PII data on the back of a PI on the back of an API breach. So these things are in effect today. Now, if you look at the OWASP API Top 10, you can also interpret it as a cybersecurity framework to some extent. So this is from a SANS survey, a fairly recent SANS survey on API security, where they asked how do organizations define application risk and API risk, and just over half of them sort of chose to say that OWASP API Security Top 10 is a way for them to classify that risk, and we see that it sort of gets people on the same page to some extent. If you think about all of the stakeholders involved in APIs, API program owners, designers, developers, application security folks, network security folks, all of them have to sort of get together and figure out how to implement security end to end when it comes to APIs. So a framework like the OWASP API Top 10 is a really good and interesting starting point to get everybody to sort of speak the same language and figure out a good sort of unified approach going forward. If we look at the old version compared to the new one, so the 2019 one on the top of the slide there compared to the 2023 version, we see that some, or actually quite a few categories survived. Some were consolidated, some sort of changed positions a little bit, and only 3 new ones were sort of introduced. So that means that the risks are sort of changing, but at the same time, it also indicates that people are still struggling with figuring out these issues that were identified a couple of years ago. So a lot of these API security vulnerabilities are still in the realm of authentication and authorization based problems, which have been identified since a long, long time, and people are still struggling with it, meaning that existing approaches aren't really a good fit to secure customers going forward, especially in light of these newer and more sophisticated types of attacks. Now, one caveat that I did want to mention when it comes to the OWASP API Top 10 is that there's a group of people that created this list. This group of people are some of them work for API security vendors. What they did is they put out a call for data before they released the list to figure out so what are actual customers seeing in production environments and so on, what breaches are they experiencing, what type of issues are they running into. But they didn't collect any data. Like there wasn't a lot of input from the general public. So they sort of went ahead and took what they knew from their own customer base and their own experience and sort of massaged that into the new OWASP API Top 10 list. But the reason that I wanted to point it out here is that to some extent, this makes it a bit more theoretical. The other part of this is that the next time we're thinking about updating the OWASP API Top 10, we should figure out a way to have more input from the general public to make sure that it more closely matches, I would say, the practical issues that people are experiencing on a day-to-day basis, whilst not saying that this is not the case today. But you could make that argument that we're sort of in between theory and practice to some extent. How does the OWASP risk rating methodology work? So they have the same sort of methodology across all of their top 10 lists. In this case, they look at the threat agents, which for this list specifically, of course, is only about APIs. They then figure out how easy or difficult is this to exploit. So a particular category that they describe, like broken authentication, for example, is it difficult, average, or easy to exploit? How prevalent is it? So how many um, um, issues in that category would they sort of see across their customer base and so on? How easy would it be to detect using existing tools? What would be the technical impact of such an issue or such a breach? What would be the potential business impact? So across all of these categories, they take these ratings and they then figure out the top 10 essentially. One thing that sort of is clear then is that, as mentioned before, things like BOLA and broken user authentication still are at the top of the list. So these things remain the most pressing issues and also remain quite difficult to sort of protect against and to secure in a real time, real life environment. What you see on the list here is that on the left we have the 2019 list. Everything in green made it over to 2023. The orange categories were sort of consolidated. The red ones were dropped to some extent or taken over by other categories. But you do see there's some new, more sophisticated levels of issues that popped up. One of those is BOPLA, which is a sort of new one or a more fine-tuned version of something that already existed. So we'll talk about some of these in just a second. If we just focus on the three new ones, just to give you some idea or some flavor of what the OAuth sort of is about and how to address these things. The first one that we see is the unrestricted access to sensitive business flows. So an example would be how do you protect yourself against automated attacks? Think about bots, for example. What I've put on the slide here is, let's say you have an airline app, and there's some sort of status that you can gain with the airline, like you can, gain silver and gold status and get some benefits from that. And they have a referral program where if you sign up somebody, you get additional points towards your status. Now, if somebody figures out how to trick this business flow and sign up a bunch of fake users, then delete them after they get the points awarded, they can sort of misuse that business flow that exists to get them the result that they want. And it's very hard to protect yourself against this because that business flow needs to exist, right? That's the service that you're offering. But at the same time, people are figuring out how to misuse or misappropriate that sort of business logic of the API. So that's a very difficult type of attack to sort of protect against. So in terms of mitigation, you then have to look at patterns of usage. Like, is this human behavior or is this more akin to a script or a bot operating? And then you can implement things like, verification using CAPTCHA and so on to protect these business flows. But that's one of the new ones is unrestricted access to sensitive business flows. The second new one is server-side request forgery. This sort of made it over from the more traditional web application security top 10 list. So what we see here is that it's about an issue where an API would sort of request or fetch a remote resource and then doesn't validate that sort of input from in this case the attacker. So that way you can sort of have this system execute anything you want that sits behind that remote URI or URL, or get more information than you're supposed to be able to get. So for example, here it's an attacker understanding that they can do a curl to a specific metadata service from a public cloud provider, and get back a bunch of data that they weren't supposed to have access to. So to mitigate against this type of attack, you're looking at things like isolating resources, sort of make sure that you can't fetch these internal versus external resources, so you're not exposing these services towards an end user, for example. The third one, and number 10 on the list, is unsafe consumption of APIs. So what we see here is that developers tend to trust data that is coming back from third-party APIs more than data coming from user input. So this is about somewhat blindly trusting an input they get by calling a third-party API and then sort of running with it. So in this case, let's say a bad actor can manipulate the shipping address based on a third-party map provider. So they can sort of redirect the shipping location to a location that they control, and then potentially steal goods from a valid user. So, in order to sort of mitigate against this level of attack, you would look at sanitizing input and making sure that there's a sort of end-to-end trust chain between your service and a third-party provider. a, a quick couple of other examples, talking about sort of that new BOPLA vulnerability or new BOPLA category that was introduced, just to sort of contrast it with what already existed and still exists today in terms of the top 10 list. So this is sort of based on an actual issue that was detected a couple of years ago with an e-commerce service provider, so a platform that you can use to build your own e-commerce environments. So the idea would be I could register myself as the bad actor to be a partner to this e-commerce provider. So let's say you're running an e-commerce website, you have partners that sell goods through your e-commerce site. What I could do is I could register sort of myself as a partner, even though I'm not actually a partner of your e-commerce platform. I could accept myself using this broken function level authorization problem. So that endpoint was known. That endpoint is supposed to only be used by the store owner, the e-commerce owner. But if you call it directly, you could create a post to it and accept yourself as a partner. Once you're in that network, then you could then leverage a BOLA level attack, whereby you could sign up additional fake partners or change the IDs of existing partners. So the idea is then you could manipulate who has access to that environment. And then finally, in the more granular level of issue that's now been added to the OWASP API Top 10 with BOPLA, you could then, for example, change the inventory count of a product. So you are sort of benefiting as a fake partner from creating that issue in that legitimate e-commerce website. If you then sort of take a step back and look at the broader picture of API security and where you would implement it in an environment, what's sort of clear is that API security is a very broad concept, meaning you have a lot of existing security solutions, point solutions, or broader platforms where you can enforce some part of the API security picture, but it's really hard to do it end to end. And it's really hard to cover all of your bases because behind an API, you basically have an entire IT ecosystem operating. So what you see here is I have a user using a mobile phone, for example, that is, calling this acme.com order API to order something. But what's happening on the back end here is that you have your internal application that will take part of some of that flow, but you also have third-party services like shipping services or mapping services to pull data and exchange data with. So then the question becomes, if you look at the sort of yellow orange boxes on the screen, there is where do you implement security validation and security controls to make sure that this is end-to-end protected. So you have to protect the application side, you have to protect the API itself, so the middleman between the consumer and the application. You have to validate the API specification so that people integrating with your system on the front end can do that in a secure way as well. From a gateway perspective, you have to look at things like enforced authentication and authorization, controlling traffic to that endpoint, doing things like bot detection and so on, making sure the system isn't overwhelmed at certain points in the day or certain months in the year and so on. From a WAF perspective, you can then look at things like security validation, things like SQL injection and cross-site scripting, but also rate limiting and so on. So just to show you that it's really a hard problem to solve, and that is why you now see dedicated API security platforms like No Name sort of addressing this full end-to-end picture with a centralized approach, but pulling in those existing systems and devices like web application firewalls and API gateways. At a high level, so I won't go through this entire list end to end. This is included in a white paper that I'll link to at the end of the session as well, so you can read it in full detail. But what we did here is we split out each category and then looked at how can I mitigate it using existing approaches like creating secure code, but also leveraging my web application firewall, leveraging my gateway, and where do I fall short by using that approach. So where do I then need to look at a broader platform like No Name to address sort of the missing pieces from the puzzle here. One of the things that we've noticed more and more is that there's sort of increased interest in APIs, which is good. There's also an increased interest in APIs from the malicious side, which is bad. And then there's also a lot of educational content now. So one of the sort of things that we see is there's a lot of training content on things like YouTube and so on, and Twitch, where you can register, log in, sometimes for free, and then look at these security researchers while they go through attacking an API or attacking an API endpoint and sort of showing you tests and what you can try to accomplish yourself using a sandbox environment or sometimes even a live environment. One of the things that's pointed out here from Insider PhD is these business logic errors. So what I alluded to before is that business logic flow is a very hard thing to tie down beforehand because you actually want to expose that to the outside world. That's your functionality of your API essentially. So what Insider PhD is suggesting here is figure out a way to inventory the steps required to do something with that API. So think about an order process and on an e-commerce site, for example. So searching for an item, putting it in your shopping basket, going through a shipping address process, going through the payment process, etc., and then figuring out if there's a step that you can skip whilst the backend system still accepts that flow. So those are sort of the types of attacks we can sort of look at and sort of validate. One example of such a business logic flow error is this Coinbase issue from a while ago, whereby somebody figured out to trade cheap coins for the price of expensive crypto coins. So the idea is that these types of issues are much more prevalent than we think. In case of Coinbase, this was disclosed, right? So this was on the basis of a bug bounty. So as far as we know, it wasn't misused in production. But these types of issues are real world. So a lot of these systems exposed through APIs are vulnerable to these types of issues because it's so very hard to figure out beforehand how to translate the business flow that you're offering from an API perspective into static security rules that you can implement in an inline device. That's an impossible task, really. So that's why you sort of need to look at it from a broader platform perspective. Now, why are APIs so interesting these days from an attacker perspective is that they are really the entryway into the data of a customer. So if you think about the most valuable asset that an organization has beyond its human capital, of course, is like the data they own. The data is sort of what makes them unique. It's sort of what makes you competitive against your competitors. So getting that data is sort of the thing that these malicious users and these attackers are after. What we've noticed in the past is there's always been this sort of front door or system between the data and the attacker, meaning you had some sort of application that you needed to breach in order to get to that data aspect. Now, over time, what happened is we've built an API, and that API, if you know what you're doing, simply responds with data if you can manipulate it in the correct way. So now the easiest path to that data is no longer attacking the environment, like breaching the network, figuring out how to breach the application, and then getting the data out. It's actually just querying or quote unquote attacking the API and getting through the data that way. So sort of what you see on the right side of the picture here is that as an organization, you can go through this evolutionary step of changing my application side. So at some point, you decided, for example, maybe I'm running a monolithical application on the basis of an EC2 instance that's getting its data and storing its data in an EBS block store. Then a couple of years later, we decided that we were going to switch to container services because that made more sense for the application profile. And then finally, we ended up with a serverless application on Lambda and S3 storage. That's all fine, but from the attacker perspective, as long as there's an API in front of it, the backend can change, and the attacker doesn't even have to figure out how to change with the backend. As long as they can figure out how to manipulate the API, then that backend isn't that important from an attacker perspective. They can just get to the data. So that's why this has now become sort of the focal point, is because it's such a rich gateway into what you own as an organization. The usage of APIs really has skyrocketed as well. There's sort of many reasons for that. Of course, we've changed our architecture in new and interesting ways. We build hybrid infrastructures, meaning we have monolithical applications, we have microservices, distributed applications, we have on-prem environments, we have public cloud, we have SaaS. We're doing things like continuous development, which also leads to continuous abandonment to some extent, right? If it's super easy to develop new services, to develop new applications, people also move on from your organization and things sort of get abandoned to some extent, and these services remain active or remain publicly available and aren't then protected in the same way or aren't then considered in the same way from a security perspective as the newer services that you're launching. There's things like industry standards. Think about PSD2, PSD3 in banking environment, open banking, FHIR APIs in healthcare, and so on. Through M&A activity, you might acquire a company that has a completely different API-based standard than what you're working with. So now you have to support, multiple different API standards, multiple different development standards, which makes it more difficult. And then, of course, there's also this concept of the explosion of API since 2002, when Jeff Bezos sort of announced that Amazon should switch to a services based interface environment for any service that they were going to release. So, meaning everything had to be standardized. He didn't necessarily call it APIs or didn't call out REST APIs or anything like that, but he said everything has to work on the basis of standard interfaces. That's how we're going to integrate all of these different environments within Amazon and get them to collaborate. And then he sort of made it a mandate by saying, if you don't agree with what I'm telling you here or what I'm asking you here, you're no longer a part of Amazon. So that really kicked off this drive towards standard interfaces and standard APIs. Security doesn't work at the moment when it comes to APIs, meaning there's a lot of public breaches and there's much more breaches that aren't public, of course, on the basis of APIs. But we recently had things like the Optus Telco breach. A lot of PII data was lost. A while before that, we had the Peloton API that leaked personal information from Peloton members, including the President of the United States. There's this research project on the API vulnerabilities of 16 major car brands and their mobile applications. So a lot of this data is up for grabs on the basis of these APIs, which means that we are severely lacking in protecting sort of what's important going forward from an organizational perspective. Switching gears a little bit, I wanted to talk about the critical capabilities when it comes to API security. So, what you see on the slide here is based off of a Gartner research report where they looked at, well, what do we need to think about if we are serious about securing these newer types of environments on the basis of APIs? And they sort of pointed to these five main domains. First one being discovery. So the idea is you can't protect what you don't know about. So you have to discover all of the APIs that you have in your environment, internal APIs, external APIs, developer APIs, production based, etc., etc. You have to get the full API landscape, have a full inventory of the API landscape before you can then think about the second domain, which is posture management. So how do we de-risk the environment in such a way that we take out all of the security misconfigurations that open up our system and our organization to potential attacks? So these could be things like misconfigured APIs, but just as easily could be things like routing misconfiguration in a network, exposing a backend API service to the outside world when it shouldn't be. So things like that are part of that posture management domain. Testing, of course, is extremely important when it comes to API security in the sense that if we can avoid releasing a vulnerable API into production, that is going to save us a lot of headache. So there's there is a stat that says that it's up to 640 times more expensive to go in and fix a bug after it has been released into production than to detect and fix the bug during the development life cycle. So automated testing of security vulnerabilities during pre-production, that's really what this specific domain is about. And then the runtime. So APIs are very usage driven, meaning you have to look at real time communication of the API to really understand that business logic flow problem that we talked about before. What I mean by that is you can't really upfront establish all of the flow logic and then create a set of static security controls that you can then import in your web application firewall, for example, because it sort of is user dependent, it is functionality dependent, and it is extremely dynamic and open to change constantly. So that is why you have to look at the real world usage of those APIs, take that together, use machine learning to figure out a baseline of expected or normal behavior for each individual endpoint. And then once you have that baseline understanding of this is how a specific endpoint is supposed to be used, like if I'm Amazon, this is the flow of the e-commerce sale for an item from an end customer. And then you can sort of look at, are other people using that flow in the same way, or is somebody trying to manipulate that flow somehow, which then points to an outlier versus the baseline, meaning probably a malicious actor that we need to block and remove from the equation. And then of course a big thing is access control. We have to make sure that authentication and authorization is properly defined and also properly controlled, both using those inline tools, but then also validated using a broader platform. The way that we've addressed these critical capabilities is they sort of match the pillars that we have in our own platform. So you have this logical diagram of the no-name security platform here, whereby access control is done to some extent in the systems that we integrate with. So things like a CDN, a load balancer, a web application firewall, and API gateway, which is also where we get the traffic from to do our own analysis of the API security in your specific environment. So it can come from those traffic sources. It can also come from network cloning. It can come from integrating with logging systems in the public cloud, integrating natively with applications like IIS, Kafka. It can even come from things like an eBPF-based sensor. So if you're implementing things like end-to-end encryption, think about a Kubernetes environment with mutual TLS, things like that. eBPF could be a good answer there. Or it can come even from a sort of inline proxy that we provide ourselves. The idea is we take this input from anywhere, and then using our ML powered platform, we figure out what good behavior looks like. We give you full end to end discovery of all of your APIs. We de risk it using posture management. We provide runtime protection using our runtime pillar. So, looking at real time communication, blocking attackers in real time. And then we have a separate part of the product. It's integrated, but it's a sort of separate solution called active testing, where we will help your developers create secure APIs so they don't need to be shielded in the first place, or ideally and theoretically don't need to be shielded in the first place. So what I wanted to do now is jump into a quick demo, just a couple of minutes to show you an overview of how we've implemented the OWASP API Top 10 in the system and how you can relate findings and issues back to that top 10 list. So here we are with the demo environment. So what you see here is we've classified our findings, meaning security misconfigurations and so on, and the runtime incidents based on real-time traffic on the basis of a framework that you can select. So here you have the option to still select the 2019 list or go for the newly released 2023 OWASP Top 10 based on where you are organizationally vis-a-vis that framework, of course. So the idea is we classify it this way so you have an easier ability to triage what's going on in your environment and work towards remediating those issues. So, besides that top 10 list, we classify findings also based on a severity level. So, is it a low, medium, high, or critical issue? Meaning you should look at the critical issues first, of course. And then next to that security indication, we also give you that full inventory. So, think about those 5 critical capabilities. Discovery is the first one. So, we discover all of your APIs, including the ability to look at APIs based on specific compliance and conformance frameworks. If you just look at all of them for demo purposes, you can see we give you excruciating detail about each API endpoint, including any issues that we find beyond also the OWASP API top 10. So this could also be, specific data policy violation issues that you can put in the system yourself. Some we have out of the box. If they're related back to the OWASP, you can see them pop up in this list as well. So for example, we have some posture issues on this one as well. So discovery is a part of that. Second part of those critical capabilities are then posture. So looking at findings, for example, here we have a finding that says we have an internet-facing API which exposes sensitive data, but you did not implement any authentication on that API. So that is a clear misconfiguration. We'll show you which category this falls under from an OWASP perspective. If you click on that, we'll give you the detail of what we detected, including a full evidence chain as well, and then we'll guide you towards a remediation step. So the idea is, for example, we could automatically create a ticket, send it to who's responsible for implementing authentication and authorization from a gateway perspective, for example, or on the code level on the API, and that way you can go ahead and remediate that issue. Then the fourth pillar, the third pillar is testing. We'll get back to that. The fourth pillar is that runtime issue. So if you look at runtime incidents, for example, you can see them here. We can also list it based on attackers. So if we identify attackers in your environment, so this is time-based. Let me just make that a bit broader here. So for example, attackers we've detected on the basis of identification. This could be based on things like a JSON web token, based on an IP address. whatever we sort of get from the integration point and so on. And then you can look at these individual attacks, and you can block these attackers, or you can create an allow list around it as well, or you can create a policy to automatically take some action as well, like update an ACL on your firewall to automatically reject an IP address, for example. So that's based on that runtime category. Then the third pillar, to go back to it, is the testing piece. So in pre-production, we also look at the OWASP API Top 10, of course. So the idea is we want to guide developers in creating secure APIs in the first place. What you see here is a number of applications that we've associated with active testing. So these are the APIs currently under development, let's say. So if I click on one of them, what you can see here is that we've done a number of scans against this particular application. We identified all of those APIs. We've identified 228 issues. Two of them have been closed in the meantime. If we drop into the issue list, you can see we've categorized it on the basis of OWASP here as well. And then if you then, for example, look at one of those issues in detail, we'll show you exactly how that test went about. So what is the timeline of the test that we performed, the full request and response, our findings, and a remediation action, so you can make sure that this doesn't get released into production. So that's part of the testing um, capability as well. So that is sort of the super high level overview that I wanted to provide. Of course, if you go to nonamesecurity.com, you can sort of register for a much longer demo as well. But for this webinar, that's sort of where I wanted to focus on from an OWASP perspective. I just wanted to point out two quick resources before we jump into the questions, if there are any. So we do have a full white paper that I created, which is, I think it's 40 plus pages long at the moment, describing each category in the 2023 OWASP API Security Top 10, what it looks like, how to detect it, how to mitigate it, how our platform specifically looks at that specific category, and what to do with no name to sort of protect yourself against each one of those categories. Outside of that OWASP list, we also have the API security workshop that we offer, which is a free workshop, online or in person. If you go to that URL, events.nonamesecurity.com/workshop, you get the agenda of where we're running these workshops. So the idea here is we'll give you a lab, including a vulnerable API application, and then show you how to quote unquote hack that application, and then leverage a tool like No Name to make sure those attacks are detected and then remediated and mitigated against. So with that, I wanted to go back to you, Keith, if that's fine, to check if there's any questions.
Yeah, absolutely, Philip. Hey, great presentation. Love the demo. Love the emphasis on API security, which is just so crucial these days and getting more crucial all the time as APIs continue to explode. We do have a number of great questions, and we'll get to as many as we can for the rest of our time today. So, the first one for you: does your solution go beyond addressing the OWASP API top 10? So obviously this is the top 10 attacks, but there are certainly more than that. So what is the, how far do you go with that?
Yeah, I think that's a great question. So the top 10, because it's in the name, right? Top 10 meaning there's a longer list of issues than just the top 10 issues. So yeah, from our customer base and prospect base, we do see attacks that aren't necessarily part of those categories, even though you can potentially classify all of them as one of those categories just to make it easier. But yes, we do address also issues outside of that top 10 list. You have the ability to create your own policies to some extent as well, which can detect things outside of that list. But what's important here is that the core of the platform is based on user behavioral analytics. So we will always look for each individual endpoint, how an API is used by our user base, which then allows us to detect anything that is outside of that normal behavior baseline. So the idea would be, even if it's an unknown attack, something that hasn't been described, there's no CVE for it, like it's an unknown new type of attack against an API, it would look different than normal behavior. So we would be able to detect it and then give you the necessary insight to implement some remediation. So that's much broader than the OWASP API Top 10. So the OWASP API Top 10 is a good starting point, I would say, but yeah, the platform goes way beyond that for
And
sure.
there's a question related to that. You mentioned a minute ago unknown attacks. So that was another question we had. What about the protection against these? And I guess that includes 0 days as well, doesn't it? What is the what is the answer for that?
Yeah, absolutely. So if you think about these unknown attacks or like 0 days attacks, for example, as you rightfully state, the way that we address those is twofold. So first of all, using that posture management, you can de-risk existing APIs. So the idea is we want to get rid of as many vulnerabilities as possible before an attacker even attempts to look at your environment. So if we can get rid of those authentication issues, for example, that we saw in the demo, or can get rid of routing issues in the network, or avoid implementing like weak cipher encryption, things like that, de-risks your environment to a great extent. But then, yes, there's always going to be this issue of insecure code and 0 day vulnerabilities, because it's impossible to create 100% secure code, right? That's simply not going to happen anytime soon. So then we sort of fall back to that runtime security module that does that behavioral analytics and figures out how to differentiate between expected behavior versus unexpected behavior. So these unknown attacks would show up as unexpected behavior. It will be flagged that way, and that's what allows you to go after these unknown attacks. Yeah.
Okay, great. Another great question for those who are thinking about implementing API security. Where's the typical place that you start when you're doing that?
Yeah, I think discovery is the answer. Uh, what we see when talking to customers, but also talking to resellers and partners, and even talking to industry analysts, is that the discovery piece and the inventory piece and the API asset management piece are really, really the first step that a customer should look at when talking about API security. So we can implement, the most capable security system for APIs in the world, but if you miss a couple of endpoints which aren't then protected, then those are going to be your avenues towards a breach. So step one is always going to be understand what you have and build a full comprehensive end-to-end inventory of all of your APIs internally and externally, and start from that point, like figuring out the API assets that you have. I think that's always going to be the correct first step.
Okay. All right, great. I think we have time to squeeze in one more question now today, Philip. So here's one. Who should be responsible for looking after API security? Who has ownership? Is it one person? Is it a team? I don't know if there's a general sort of opinion about this.
Yeah, that's an excellent point. And honestly, I think as an industry, we're sort of still figuring that out. So APIs are fairly new when it comes to API security. APIs have been around many decades since the 60s, but API security has sort of come to the forefront recently. And what we're sort of figuring out altogether is, well, who owns API security? Because you have API program owners, you have people who have to design and develop the APIs, you have people who have to look after the infrastructure that's powering the APIs. Maybe that's on-prem, maybe that's in the cloud, maybe you are offering it using a mobile device, etc. So there's many stakeholders when it comes to APIs. So that's why what we see more and more is that it sits in the CISO organization, or it sits in a sort of API security center of excellence that pulls together all of these stakeholders and then holistically looks at API security end to end. I think that is probably going to be the correct approach going forward. It does fall more and more in a sort of application security team, application security environment. But yeah, as mentioned, it has a lot of stakeholders, and we have to align all of those stakeholders to really be successful with API security, I think.
Oh, yeah, absolutely, for sure. All right. Well, Philip Verlooy, thank you so much for your presentation, for letting us know what No Name Security is doing, your innovations for the new OWASP Top 10. That's something that everybody should be checking out as well and seeing how those trends are potentially affecting their security. Thanks so much again for your time today. We really enjoyed having you on.
Thanks, Keith. My pleasure.
Thanks, Philip, for putting together a great presentation and for all of your insights in the Q&A about API security. Hard to think of a topic that is more urgent right now, more necessary, and in some ways really is I think underplayed, underemphasized. It needs a lot more coverage than it's been getting. So hopefully we did a little bit about that today. We really appreciate your time and for being on with us. Now, before we wrap up, though, we do have one more piece of business today, and that is the Amazon gift card prize drawing. Remember, as I mentioned at the beginning, that you do have to be present for the entire event to be eligible to win the prize. And we do have a winner of our $250 Amazon gift card today, and that is Larry Bogwandine from California. Larry, I hope I said that name right, and congratulations to you. We'll be in touch to get you your card as soon as possible. And with that, folks, we're wrapped for today. On behalf of the Actual Tech Media team, I want to thank No Name Security and Philip for making this event possible. And as always, to you, the attendees, thank you for being here. Thank you for your great questions. Just thank you for your engagement and for spending part of your day with us. That concludes today's event. Have a great rest of your day.